Welcome back to the GCSE Maths Pro YouTube channel. Today's video is on the product rule for counting. Now this is probably a topic that you've either not realised has an actual official name and therefore don't recognise it, or you might just have completely forgotten that it exists in the first place. Product rule, or just the word product, is a fancy way of saying multiply. And then counting is, well, we're just counting how much of something there is. So the most basic way to put it is that we're going to be using multiplication to figure out a certain number of something. Now, I'll show you actually the context a little bit more when we actually go through some questions, and you might then start to recognise it. So, for example, Simon needs to choose an outfit. He has 5 shirts, 3 pairs of trousers, and 2 pairs of shoes to choose from. How many possible outfit combinations does he have? So it's something like that where you might have sometimes 2 or maybe 3 different options of whatever context. In this case, we've got clothes, and they've asked you how many possible combinations are there. Okay, that's kind of the gist of this topic. So instead of trying to figure out and list out all the combinations, like, well, if I do shirt number 1 with, pair of trousers number 1, pair of shoes number 1, and then mix them, that would take way too long and it's not that many marks. So that's where we're going to come in with the product rule, the timesing. In this case, you literally are just going to multiply all 3 numbers together. So he's got 5 shirts to choose from, times by 3 pairs of trousers, and times by 2 pairs of shoes. So that's the multiplying, which should give us 30 combinations. Okay, this is quite a simple example because all I'm doing is just timesing together the 3 numbers. They're not going to expect you to list out all the different possible combinations and then count them yourself. So we're using multiplying to find a count how many combinations of outfits in this case there are. Now let's look at a few more examples so that you can start to see the pattern. Okay, so this next one is very similar. So Charlie is going to a restaurant. He can choose from 4 starters, 12 mains, and 6 desserts. How many possible meal combinations can he choose from? Okay, so it's very similar to the previous one. So the starters, the mains, and the desserts are all separate lists, aren't they? So it doesn't matter which of the starters he chooses, it won't then affect how many mains there are or how many desserts there are. So in this case, I can just take all 3 numbers and times them. So I've got 4 starters, then I still have 12 mains to choose from, and then still 6 desserts. None of these categories affect each other, do they? They're all very separate decisions. So I'm just literally going to type that into my calculator, and that gives me 288 different possible combinations. So some of them are as simple as that. If you can determine that whatever categories they've chosen are completely independent of each other, the same with if we go back to the first example. In this case, the shirts are very separate to the pairs of trousers and the pairs of shoes. It doesn't really matter which shirt he chooses, that won't affect which pair of trousers he can choose and which pair of shoes. Obviously in real life maybe because of colours, but if you think about this really simplistic view, the shirt category is different to the trousers category and is different to the shoes category. So we just take all 3 numbers as they are and multiply them. Now the next example is kind of like a part A and a part B. The part A is very similar to what we've just done, and the part B then shows us where these questions could differ a little bit in terms of the numbers that we use. So, Julia has to decide on a lock combination. The code needs to be 3 digits, and each dial can be set from 1 to 9. How many possible combinations does she have to choose from? Okay, well, if you think about it, I like to look at the lock one. Imagine a lock in your head with the 3 different dials. When I choose the number for the first dial, how many options do I have to choose from? Well, from 1 to 9, that's 9 options, isn't it? Then, if I were to choose the second digit from the second dial, again, how many numbers do I have to choose from? Well, 9, again, isn't it? And finally, for the third dial, for the third digit in my code, how many do I have to choose from? Again, another 9. So this part of the example is where it's very similar to the previous ones. What number I choose for dial number 1 doesn't affect what number I choose in dial number 2 and dial number 3. I still have 9 options all the way through. So 9 times 9 times 9 is 729 options or combinations. However, when I then go to part B, you'll see how that could actually then be more specific and differ. So this is like part B of our question. We've still got the same lock, and they've now said if the lock combination cannot repeat any of the same digits, how many combinations does Julia have to choose from? So for the part A, we just didn't account for the fact that actually we would have obviously combinations with multiple digits. So for example, we could have had 555, we could have had 232, they've repeated digits. In the first part of the question, they weren't very specific about that, so we just assumed that we could choose 9 from the first dial, 9 from the second, and 9 from the third. In this case, they've now made it more specific. If we can't have any repeating numbers, we'll go through the same process again. So imagine the first dial. How many numbers do I have to choose from? Well, because it's the first one, I can choose any of the 9, because I haven't chosen any yet, have I? It's the first dial. So I've still got 9 there. However, when I get to the second dial, I've technically already chosen one digit from the first dial, so I cannot repeat whatever that digit is. Now, it doesn't matter which of the digits I chose in the first dial, it's just the fact that I already chose one. So how many options do I have to choose from, or how many numbers can I choose from in the second dial? Now it's gone down to 8. Because whatever that first number was, I can't repeat it, so I can't choose it again. And then if we think about going to the third dial, well, I've already chosen the numbers for the first and the second dials. So I've already chosen 2 numbers. So how many numbers do I have to choose from in the third dial that aren't then going to repeat themselves? Well, that would be left with only 7, wouldn't it? So do you see how in this instance it is slightly different, because we're choosing numbers from, if you imagine, the same pool of numbers. We're not imagining the 3 dials as separate categories anymore. We're imagining them as one category. I've already chosen one number, so I can't repeat it. I cannot choose it again. So there's 8 left. And then I choose another number, so then there's only 7 left. And that would actually give us 504 possible combinations. So you can see we've lost just over 200 combinations of the ones that would have repeated numbers. So this is where it can vary slightly, okay? It's not just as simple as timesing all those numbers together all of the time. You just have to check the context of the question. So there are 20 teams in the league. Each team has to play the other teams twice. How many matches are therefore played? So if you think about it, when I'm first picking let's say I was going to pick one of my first teams, well, how many do I have to choose from? 20. Times it by, how many other teams do I have to choose from? Well, one team can't play itself, can they? It's the same kind of scenario with the lock one where we can't repeat the same team. So the actual number of other teams that we can put that first team against is then 19. So I would do 20 times 19, which gives me 380. Okay, so we've worked through questions where they've just asked us how many combinations there are. There is the possible chance that they could ask you a slightly different version of that question now. So for example, here we have, Hayley is going to buy a new car. She can choose the colours for the car body, wheels and interior. There are 15 different car body colours and 4 different wheel colours. The total number of combinations Hayley can choose from is 420. So how many interior colours are there? Do you see how this one, they've actually told us the total number of combinations, and we need to work backwards to find out one of the original quantities. I would set this up in the same way as if I were to just do this question in the correct order. So normally I'd say, right, okay, there's 15 different car body colours and there's 4 different wheel colours. The car body colours and wheel colours are completely separate categories, aren't they? They don't affect each other. So I can just use 15 times 4. And if I knew the number of interior colours, then I would times it by that, wouldn't I? Because again, that's a separate category. In this case, I'm just going to use the letter X to represent the interior colours, because I don't know what it is. Now, in this case, they've actually told us that that would equal to 420, wouldn't it, that calculation? Do you see how if I set it up like this, it's effectively just an equation, isn't it? And now I just need to rearrange and solve the equation for X. So first I would do 15 times 4, which gives me 60x is 420, and then from here you can quite clearly see we need to move the 60 by dividing. So 420 divided by 60 is actually going to be 7. And there we go. The number of interior colours there are to choose from is 7. So you need to know how to do this process, not only in the correct order to find out combinations, but also if they give you the number of combinations, how you could work backwards. The other thing to consider is that this number here should always be a whole number. Because you can't have like 7.5 colours, can you, for example? Sometimes they ask you if a scenario is possible. You just work out, in this case, the one that was missing, and if it's a whole number, then yes, it's very possible. If you get a decimal number, then you say no. So our last question here is a little bit similar to the previous one. Tom is going to buy a sofa and a coffee table. There are 12 different types of sofas and some different coffee tables. Could there be 202 possible combinations of a sofa and a coffee table? So I'm going to do exactly the same thing where I set up that equation. So I would do 12 times by the number of coffee tables, Because the sofa category and the coffee table category don't really influence each other, I can choose whichever sofa and whichever coffee table. I just multiply both of them straight away. Because I don't know how many coffee tables there are, I'm going to use the letter X. So, they've said, could there be 202 possible combinations? So I'm going to write it as if it does equal 202, and then solve this equation. So I would obviously have to divide both sides of that equation by 12. So 202 divided by 12, and we see what it gives us, should be the number of coffee tables. As you can see, we've got a decimal, we've got 16.83 recurring. So does that mean that there could be that many possible combinations or not? Well, think about the context. 16.83 coffee tables. Is that possible? Not really. We can't have 0.83 of a coffee table. It'd have to be a whole number, wouldn't it? So if you get a question like this where they say, could there be that many possible combinations of whatever it is? Do the calculation and see if you end up with either a decimal or a whole number. If you end up with a decimal, your answer is, therefore, no. If you do end up with a whole number, it doesn't matter what number it is as long as it's a whole number, then you could say yes. In this case, we have to say no. So that is everything you need to know for product rule of accounting. It is a very small topic, however, you do get an extra 2 or 3 marks for it very easily. Just make sure you times everything together. So thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.